Hello, my dear students. How are you all? I wish and pray that you all are fine and your family. So, in this video, we are going to revise chapter number two, basically a part of chapter number two, that is work. Okay. So, what is work? Work is quite an ambiguous word. We use this word very frequently in our daily life, like a student while studying, after doing some homework, he say that I have done a lot of work. Now I need some rest with the mobile phone. है ना? So, for example, software engineer, what he do? Whole day he sits with his laptop and do some programming. So he's doing a work. At the end of the day, he's tired. And for example, a teacher like me, I'm standing and delivering this lecture. So I'm doing some work. Okay. So we all are doing some work, but this type of work is not fall under the category of work in physics. Okay, so it means that in physics work has some different meaning. So in physics, what is work? We can say that if we apply some force, okay, we will apply some force on an object and that object displaces from its position. Okay, what I'm saying that you apply some force on the object and that object displaces from its position. If it is done, then work is done. So basically in physics, to understand work, we need three things. We have force, we have object, and we have displacement. For example, if you push some table and that table displaces from its position, then work is being done. Okay, another example, like you are taking out a bucket filled with water from a well. So you are doing work here also. How? You are applying force on the bucket through the rope and you are pulling it. You are applying force, so and there's a displacement of the bucket also. So we have done work. Okay, so in physics, meaning of work is you apply force on an object, that object displaces from its position, and if there is displacement, work is being done. Okay, for example, you have a table and you have applied a force of 15 Newton on it, and it displaces, say, by 5 meter. So how much work you have done? You have done some work, but how much? That we need to calculate. Okay, for that we need a formula, and formula will come from the definition. Okay, formula is just the mathematical form of definition. So what is the definition of work now? Okay, so in the simplest form, अगर मैं simplest definition की बात करूं तो work is defined as the product of force and displacement. ये तीन चीजें तो हैं, work, displacement and force. So work is the product of force and displacement. Simplest है ये, ठीक है, इससे easy definition नहीं हो सकती है, ठीक है, लेकिन ये definition हर बार काम नहीं करती है. चलो देखते हैं, इसको समझते हैं. Look, in this example, I have taken an object. We applied a force of 15 Newton and that object is being displaced by 5 meter. Okay, so how much work we have done? We apply the formula F into S. Displacement के लिए आप कोई भी letter use कर सकते हो. You can use S or you can use any variable. You can use D also. Okay, F into D or F into S, whatever. So F into S, what is the force? 15 Newton. What is the displacement? What is the value of S? 5 meter. So 75 is the answer, and unit is Newton meter. Okay, Newton meter. It is also a unit of moment of force. Okay, so where we will not use Newton meter, we will use joule. So joule is the SI unit of work. We will discuss it later. So right now we have done the work, 75 joule, and it is a scalar quantity, so we do not need any direction. But force and displacement are scalar. No, it's vector quantities now. So force and scale displacement are vector quantities. Okay, so we have to consider their direction. So in this particular numerical, in this particular example, what are the directions of force and displacement? You can see force and displacement both are in same direction. In this particular example, force and displacement both are having same direction. Okay, so this formula will work only when, ध्यान से सुनो इस बात को, this formula or this definition will work only when force and displacement are both in same direction. तो ये हमें याद रखना है कि ये जो फॉर्मूला है, it will work only when force and displacement, ध्यान से सुनो, are both in same direction. ऐसा कंपल्सरी नहीं है. देखो जरा, I will change the slide. It's taking some time. Yes. Okay, look at in this example. Look at in this example what is happening here. Okay, look. ध्यान से देखो क्या फोर्स और डिस्प्लेसमेंट सेम डायरेक्शन में है. इस एग्जांपल में भी we have applied a force of 15 Newton and displacement is 5 meter. Okay, so what is the work done now? If you use the same formula F into S, it will not work here. Why? Because force and displacement are not in same direction. So what is happening here? You can see that force is being away from displacement by some angle theta in this diagram. Okay, so in the definition of work, you can say that work not only depends upon the force and displacement, it also depends upon the angle between the direction of force and displacement. So the right formula should be W is equal to product of force, displacement and cos theta. We have taken cosine of the angle between F and S. So this formula will work every time. Okay, so work not only depend upon the force and displacement, but it also depends upon the angle between force and displacement. So we have to deal with this formula. Work done is equal to Fs cos theta. There are three things now: force, displacement, and because force and displacement are vector quantities, so we have to consider the direction also. So for that direction, we need F angle theta. So formula is Fs cos theta. Okay, we are revising this thing. Chalo. So can we do question number 1 with the help of this example also? Yes, we can do. How? Look. In the first example, we have force 15 Newton, we have displacement 5 meter, and what is the angle between force and displacement? Look at these two pens. Look, suppose this pen is representing the direction of force, okay, and this is displacement. Both are in same direction. So what is the angle here? Look. Now, what is the angle now? What is the angle now? It is 90. Okay, so now look, now what is happening? Angle is decreasing and it has become 0. Okay, so now both the pens are in same direction and the angle has become 0. So in this example, the angle is 0 degree. So we will apply the formula once again. Look at here. So example number 1, well, we will use the formula Fs cos theta. Now we'll put the values. F is 15 and displacement was 5 meter, and what is theta here? 0 degree. So cos 0, and cos 0 is 1. So we will have the answer again 75 joule. Okay. Now example number 2. Now what is the force? 15 Newton, displacement is 5 meter, and let's say this angle is 30 degree. Angle could be anything from 0 to 180. So let's say we have 30 degree. So so by putting the values, cos 30 is √3/2. Now we'll use this formula and we will do simple mathematical calculation and we have 65 joule. Now look, the answer is different because angle has been changed. Now answer is having some less value. Okay. So what is the formula for work done? Fs cos theta, where theta is the angle between direction of force and the direction of displacement. Okay. Now we will discuss the unit of work. So Newton meter नहीं बोलेंगे क्योंकि Newton meter is the unit for torque or moment of force, we'll use this word joule, and the symbol will be capital J. So we can say that 1 joule is equal to 1 Newton into 1 meter, and we can have a statement also that if on applying a force of 1 Newton, अगर हम किसी बॉडी पे 1 न्यूटन का फोर्स लगाएं and that body displaces by 1 meter in the direction of the force applied, then we will say that 1 joule of work is being done. Okay. Now CGS unit of work is ERG, ERG. Okay. CGS unit is ERG. We have to learn these things. Okay. So now we have the relation between SI and CGS unit. It is 1 joule is equal to 10 raised to power 7 ERG. Okay. This is an important relation. It may come for 1 mark. चलो आगे बढ़ते हैं. Now example number 3. It is the same example. It was example number 1. Again we are discussing. Now we'll use the formula Fs cos theta, not Fs. Okay. So look at this example. We have an object. We applied a force of 15 Newton and the displacement is in the direction of force and it is of 5 meter. So what we are having here? So what is the angle here? 0 degree. Same direction, 0 degree. So F is 15, S is 5, theta is 0, cos 0 is 1. So we are getting the answer 75 joule. Okay. Now tell me, how many forces are acting on this object? One force we have applied, that is of 15 Newton. Is there any force also which is acting on this object? Yes, there are some forces also. One force is gravity. Gravity तो हमेशा लगेगी भाई. Direction क्या होता है? Downward. And one more force will also be there. It is friction. भाई कोई body किसी surface पे slide करेगी, so it will experience friction. And friction की direction क्या होगी? Backwards, opposite to the motion. Okay. Now in the second part, what they are asking, find the work done by gravity. In the first example, we have calculated the work done by the force which we have applied. Okay. In the second case, they are saying that find the work done by gravity. So what is the formula for gravity? It is mg. Okay. Now we will use the same formula, Fs cos theta. Now this time force is gravity, that is mg. Okay. Then we have displacement s and cos theta. Now what is theta here? This is important now. What is the value of theta? Look, gravity is vertically downward. Okay, always. And displacement is forward. So what is the angle here? 90 degree. So cos 90 is 0. And 0 into 245, we are getting the answer 0. So work done is 0 by gravity in this case. So work done can be positive also, work done can be 0 also, work done can be negative also, depending upon the value of theta. Here theta was 90 degree. Okay, displacement is forward direction, and so work done is 0 against gravity or by gravity. Okay, so here it means that work done can also be 0. Now look at the other next, the third case. Now they are asking that find the work done by friction. The body to move कर ही रही है ना with the applied force which we have applied, but with that force there are two forces also acting. Now they are demanding find the work done by friction. The formula is Fs cos theta. यही formula याद रखना है, यही करना है, बस values put करनी है. बस put करने से पहले you have to decide that what is the angle. So in this case, very easy. Displacement is in forward direction. Look at the pen. And look, this angle is 90, but friction is opposite. So angle is increasing from 90 to now it is 180. My angle is 180. Okay. So putting the values now, 15, 5 and cos 180. Cos 180 value is minus 1. We should know these things. And 75 into minus 1 is minus 75 joules. So in this case, work done is negative. It means that work done by the force can be negative also, okay, if the angle between the force and displacement is 180 degree. Okay, and this falls under the category of nature of work. So nature of work, listen to me, nature of work can be positive also, can be zero also, and can be negative also. And when these conditions satisfied, when angle is 0 degree, then positive work. When angle is 90 degree, then zero work. When angle is 180 degree, then negative work. Okay, and you can give many examples of positive work, negative work, and zero work. For example, pushing a table. This is example of positive work. Okay, a pulley holding a load on his head and moving in forward direction on the platform. Then work done by him against gravity is zero. Angle is 90. Gravity is downward. Motion is forward. Angle is 90. Okay. And zero work can also be there if no displacement is there. For example, you are pushing a wall. You are pushing a wall. You applied a force, but there is no displacement. So displacement is zero. So work is also zero. And what is the example of negative work? Negative work. Throw a ball. Throw a ball in upward direction. Throw a ball in upward direction. So what is the work done by gravity? It will be negative. Why? Because displacement is upward, gravity is downward, angle is 180. So example is negative work. Okay. So we will keep the topic here only. Okay. All the best for unit test and stay safe.